Welcome to True Projects. In this video, we are going to explain about the project, which is an incremental majority voting approach for intrusion detection system based on machine learning. So before getting into the execution, first let us understand what is the project about. In the world of cybersecurity, the landscape is constantly shifting. Every day, we hear about new or more sophisticated different cyber attacks that pose serious threats to our digital lives. Whether it may be distributed denial of service that brings down the websites, it may be ransomware that locks up the critical data, or it may be advanced persistent threats that silently infiltrate systems, the dangers are real and growing. As organizations become more reliant on digital systems for their operations, the need to secure their networks becomes increasingly important. One of the key tools used to defend against these attacks is intrusion detection system. So think of IDS as the digital equivalent of a security guard. It's a kind of digital security guard, which constantly monitors networks for the unauthorized access and malicious activity. So these systems they play a critical role in keeping our data safe, and also it ensures the integrity of the networks that power everything from healthcare to finance to communications. But as cyber threats evolve and grow more sophisticated, these IDS models we rely on today are facing significant challenges. So, the traditional IDS systems often struggle to keep up with the rapid space evolving threats. Why? Well, most of them are static. So, these systems may not recognize it unless they are manually retrained. So, meaning they don't adapt well to new attack techniques. If a new kind of cyber attack arises, these systems may not recognize it unless they are manually retrained with fresh data. But retraining is not a simple task. It requires large data sets and also often painstakingly labeled with the correct information, and storing these datasets takes up a lot of space. So getting these labeled datasets is time consuming and also it is costly, which makes the whole process less efficient. So while ideas are essential in the fight against cybercrime, the current methods have their limitations and need to solve alongside the very threats they are trying to stop. One of the major challenge with the traditional idea system is their inability to handle concept drift. So this occurs when the nature of the data or patterns in the network change over time, such as when cyber attacks evolve or new attack methods are introduced. For example, an idea is trained to detect certain types of malware might struggle if hackers change their tactics. Over time, these shifts make static system less effective. As a result, traditional models which rely on fixed data can adapt to these changes without being trained. So this is where the need for more dynamic and resource efficient systems comes in. Ones that can continuously learn from the new data and also adjust to these changes without requiring huge amount of labeled data every time. So in this project, we are proposing an incremental majority voting intrusion detection system, that is IDS. So this is built to keep up with the evolving cyber threats in real time. Instead of relying on single method, it combines multiple powerful classifiers that are k nearest neighbor, softmax regressor, and adaptive random forest into an ensemble model, that is voting classifier. So this combination helps to improve the detection accuracy and also improve the false alarms by using a majority voting mechanism. So it will use the majority voting mechanism where the system makes decisions based on the consensus of all classifiers. So, what makes the system more effective is its ability to adapt continuously to new data without needing to be trained. So, this makes it particularly useful in the environments where data is constantly changing, like in real time network monitoring. Essentially, it can learn from incoming data streams and stay updated on new attack patterns, providing on ongoing reliable defense against cyber threats. So this system, we have used several known data sets that are CIC IDS 2017, NSL KDD, CIC IDS 2018, and KDD Cup to train and test its performance. To ensure the system works effectively across different scenarios, we have applied different pre-processing techniques to address the issues like data balance. So here we address the issue of data balance and imbalance traffic scenarios, allowing the system to adapt to different types of network conditions. This approach shows that the system is not only accurate in detecting a wide range of intrusions, but also resource efficient and scalable, making it well suited for dynamic environments where data and attack patterns are constantly changing. So furthermore, to further improve the performance, in this project, we are incorporating the other ensemble model called stacking classifier. So this model also combines multiple individual models work together to make a final prediction. So by combining strengths of different models, this approach enhances the accuracy and also the robustness of the system, leading to better detection performance. And moving on, as the front end of the project, we have used Flask framework to build the front end. So we have used Flask framework to build the front end. So this allows users to interact with the intrusion detection system, test its features, securely access its functionality. So the front end includes user authentication to ensure that only authorized individuals can use the system, providing secure and user-friendly platform. Moving on to the implementation of the project. So first, what do we do is we import necessary Python libraries and tools for data processing and modeling. And then we load and examine data sets that are CIC IDS 2017, NSL KDD, KDD Cup, and CIC IDS 2018 to understand their structure and features. And then we clean the data by removing duplicates. So we remove duplicates and also the unnecessary columns. And then we perform the data visualization. We use visualizations to better understand the data distributions and also the relationships. And then we convert categorical data, that is categorical labels, into numerical format for model compatibility. And then we select features as X variable, that is, we append features to X variable and target label to Y for training the model. And then we have used mutual information to identify and retain the most relevant features. And then we have balanced the data set using different techniques that are original data. Directly, we have built all the models on this original data. And then we have used random undersampling technique and we have addressed the issue of class imbalance. And then we train all the algorithms on the data which is sampled using this technique. Similarly, we have also used random oversampling and oversampling. And all the models will be built on each individual sampling technique on the data, this thing. And then we split the data into train and test. So training data will be used to train the models and testing data is used to evaluate the models. After that, what do we do is we build machine learning models using the prepared data, and then those models, those algorithms will be trained on the training data set. Then we evaluate all the models using accuracy, precision, recall, FN score, AUC, and specificity and sensitivity. And we generate graphs to visually compare the performance of the different models. And here the front end of the project is developed using Flask-based front end, Flask-based framework with the user registration and login functionalities. And in the front end user, he will be able to give feature values, that is intrusion data that will be pre-processed at the backend. It will be fed with the train model. Finally, type of attack will be displayed in the front end. So this is how we have implemented the project. Moving on to the algorithms used, we have used total 6 algorithms that are KNN, softmax, logistic regression, random forest, decision tree, voting classifier, in which we have combined all the KNN, softmax, random forest, and decision tree algorithms, and the extension model, that is stacking classifier, which combines random forest decision tree with barking classifier. Among all the models built, this has performed well, so we have used it for deployment in the front end. Moving on to the requirements to implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies are HTML, CSS, and JavaScript Bootstrap. So now let's execute. To execute, we need to open the code folder of the project. So this is the code folder of the project, which contains source code files. First, let us open the notebook folder. So let's open this. So here we have data sets and also the notebook files. So first, let's discuss about the data sets. So here in the CIC IDS 2017, we have CIC IDS dataset. Here we have CIC IDS 2018 dataset. Here we have KDD Cup dataset, and this is the NSL KDD. So here total we have 4 datasets used in the project to detect the network attacks, cyber attacks. And here we have pre-processed them. After pre-processing, they are stored in Excel. So this is the CIC IDS 2017 process dataset. After pre-processing, this is the dataset that we have saved it like this. Similarly, we have pre-processed the CIC IDS 2018 dataset. KDD cup dataset, and also NSL process dataset. So coming to these Jupyter Notebook files. So these are the Jupyter Notebook files which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. So this coming to the CIC IDS 2017 Jupyter source file here, we will be loading CIC IDS 2017 dataset. We will be pre-processing and then we will be training all the algorithms on this CIC IDS 2017 dataset. Similarly, here also 2018 dataset will be loaded, that will be processed and that is saved here like this. And then all the algorithms will be trained on the CIC IDS 2017. Accordingly, KDD cup and NSL KDD. So this is about the notebook folder. Let's get back. Coming to the application, here we have static folder. So this folder consists of files related to CSS, JavaScript, and Bootstrap 4. These are important for the visual appeal of the project. In this models folder, we have algorithm information that will be loaded into the project code during runtime. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have 4 sample files in which we have test cases that we will be using in the front end to detect the cyber attacks. Coming to this signup.db file, this file is a database file which is used to store the user information. So now let's copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now open the Anaconda prompt. So here Anaconda prompt is open. Now use the command cd followed by the space. Now paste the copied path. Now click on enter. Here if you observe, current directory is changed to the code folders path. Now let's compile app.py file by using the command python space app.py. Now click on enter. This command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Let's register first. Click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in. Provide your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. As we have trained 4 data sets to detect the cyber threats, we will be detecting for each individual data set. So first, let's do prediction for the NSL KDD. Click on that. So these are the inputs need to be given for the NSL KDD dataset for the prediction of cyber attacks. Let us understand them first and then give the parameters. So first we have a service. It is the type of service or the protocol used in the network communication such as HTTP, FTP or DNS. Coming to flag. It indicates the status or the result of the connection attempt such as whether it is a successful, failed or reset. Coming to SRC bytes, it is the number of bytes sent from the source, that is attacker or the user, to the destination. Coming to destination bytes, it is the number of bytes sent from the destination, that is server, to the source. Coming to count, it is the total number of connections made by the source to the destination. Same SRV rate. It is the rate of connections that occur to the same service or protocol over a given period. Coming to different SRV rate, it is the rate of the connections to different services or protocols during a period. And here we have destination host, SRV count. It is the number of connections made from the source to the particular destination host. And here we have destination host, same SRV rate. It is the rate of the connections to the same SRV on the destination host. And here we have destination host, different SRV rate. It is the rate of the connections to different services on the destination host. We have understood what are these parameters. Let us enter them. So we have test cases in the sample folder, right? Sample file, right? So let's open that first. Get back. As we are doing prediction for the NSL KDD, let's open the sample cases of NSL KDD. So these are the test cases that we will be using for the detection. Let's enter them. As we have 5 different types of attacks, let's first keep the filter. So here, if you observe, we have total 5 different attacks. So that is why they are named as 0, 1, 2, 3, 4, 5. 0 is one type of attack, 1 is one type of attack. Similarly, 2, 3, and 4. So first, let's try with the 0 class. Click on OK. Let's try with the first test case of 0 class label where service is 65, flag is 5, source bytes are 0, destination bytes are 0, count is 116, same SRV is 0 0.1, different SRV is 0.07, destination host is 12, and the next value we have is destination host same SRV, that is 0.05, destination host different SRV is 0.06. Click on predict. This input will be pre-processed at the backend and then we will be getting the prediction by the train model. So let's wait. And here we got the prediction that attack is detected, and that attack is nothing but it is DDoS attack. So let's check with the other class label, that is the one label, one first class. Click on NSL KDD. So let's try with the first test case of class label 1, where the service is 14, flag is 9, SRC bytes are 8, destination bytes are 0. 1 is the count, same SRV is 1, different SRV is 0, destination host SRV is 5, destination host same SRV is 1, and the destination host different SRV is 0. Click on predict. As the input is being pre-processed at the backend, it is taking a bit of time. Here we got the prediction that there is no attack and it is normal. It is completely normal. Let's try with the one more test case. There are 3 more test cases pending in this data set. So let's try with all those 3. We are being pending with the second case. Click on OK. So let's try with this case. SRV, that is services 29 is flag. SRC bytes are 334. Destination bytes are 0. Count is 1. Same SRV is 1. Different SRV is 0. Destination host is 37. Destination host same SRV is 1. Destination host different SRV is 0. Click on predict. So here we got the prediction that attack is detected and it is probe attack. Let's check with 2 more remaining cases of the same data set. Service is 60, flag is 9, SRC bytes are 587, destination bytes are 8410, count is 1, same SRV is 1, different SRV is 0, destination host is 3, destination host same SRV is 0.12, and destination host different SRV is 0.17. And here we have the prediction that attack is detected, and that attack is nothing but R2L attack. It is the R2L attack. Let's try with the last case of NSL KDD dataset. Select the class label 4. Let's try with this one. Source is 24, flag is 9, SRC bytes are 339, destination bytes are 272, count is 10, same SRV is 1, different SRV is 0, destination host SRV is 225, Destination host same SRV is 1. Destination host different SRV is 0. So here we got the prediction. It is detected as U2R attack. So we have been detected with all the 5 attacks of this NSL KDD. Now let's check with the KDD cup. Click on that. Here we have same inputs, same parameters that are need to be given for this KDD cup dataset. For that, let's open the sample case of KDD. So here we do have total 5 classes. First, let's check with the 0 class label. So this is the KDD cup dataset sample cases. Let's try with this one. Where service is 8, flag is 5, SRC bytes are 0, destination bytes are 0, count is 241, same SRV is 0.02, different SRV is 0.05, destination host SRV is 4, destination host same SRV is 0.02, destination host 0.05. Click on predict. So now we will be getting the prediction. So here we got the prediction is DOS attack. So DOS attack has been detected. Let's check with the other case of the same KDD cup data set. Select the class label 1. Let's enter the parameters. Where service is 47, flag is 10, SRC bytes are 0, destination bytes are also 0, count is 1, same SRV is 1, different SRV is 0, destination host SRV is 0.01, destination host same SRV is, we have entered it wrongly, just wait a minute. Destination host SRV is 1, destination host same SRV is 0.01, and different SRV is 0.94. Click on predict. So here we got the prediction. There is no attack detected and it is normal. Let's check with one more case for the same KDD cup dataset. We have completed of 2 classes. Let's check with the second class. Click on OK. Let's try with this one. So I have entered all the parameters. Let's click on predict. So here we got the prediction and it is nothing but it is the probe attack. Attack is detected, which is nothing but the probe attack. Let's try with the one more case. Let's try with the third class label. We need to enter the first test case. You can enter any kind of test case, but I'm selecting the first test case just to show you the sample. So here, if you observe, I have entered all the test cases. Click on predict. Here we got the prediction and it is detected as R12 attack. So here attack is detected, which is nothing but the R12 attack. Let's try with the last test case of the KDD cup data set. That is the 4 class label. Click on KDD cup. We have clicked on NSL KDD. Let's click on KDD cup. Where service is 23. Flag is 9. SRC bytes are 285. Destination bytes are 261. Count is 12. Same SRV is 1. Different SRV is 0. Destination host SRV is 255. Destination host same SRV is 1 and 0 is the destination host different SRV. Click on predict. So now we will be getting the prediction. So here we got the prediction as U to R is detected. U to R attack is detected based on the given input. Now let's check with the CIC IDS 2017 dataset. So click on that. So here also we are supposed to provide the inputs. Let us understand them first. So first input we have is forward packet length total. It is the total bytes sent from the source to the destination. Then we have backward packets length total. It is the total bytes sent from the destination to the source. Then we have forward packet length max. It is the maximum size of a packet sent from the source to the destination. And then we have average size of packets sent from the source to the destination, which is nothing but forward packet length of mean. Backward packet length of max. It is the maximum size of packets sent from destination to the source. Similarly, here we have average size of packets sent from the destination to source, which is nothing but backward packet length mean. Coming to forward IET max, it is the maximum time gap between consecutive forward packets. And then we have forward length, that is forward header length. It is the total size of the headers and packets sent from the source to the destination. Then we have backward header length. It is the total size of headers and packets sent from destination to source. Then we have packet length max. It is the largest packet size in the communication. Then we have packet length mean. It is the average packet size in both the directions. We have packet length standard deviation. That is the standard deviation of packet sizes. Here we have packet length variance. It is the variability in packet sizes. We have average size of all packets in communication, average size of segments sent from source to the destination. And next we have is average backward segment size. That is the average size of segments sent from destination to the source. And then we have subflow bytes that are nothing but total bytes in a forward data flow. And then we have subflow backward bytes that are nothing but total bytes in backward data flow. And here we have initial size of backward window in bytes. So this is about the CIC IDS 2017 dataset. Let's open the sample cases of that. So these are the sample cases of CIC IDS 2017 datasets. So let's enter them. Let's check with the first test case where the forward packets are 31. Backward packets are 6. Forward packet length is 31. Forward packet length size is 15.5. Backward packet is 6. And forward IET size is 3. Header length is 64. Backward header length is 20. And then we have packet length maximum, that is 31. Mean is 17. Length standard deviation is 16.35. Let's copy it. Length and variance. Average packet size. Average forward segment size. Average backward segment size. Subflow bytes. Subflow bytes, the backward direction. And last we have is initial backward win bytes. Click on predict. So here we got the prediction. There is no attack detected and it is benign. So there is no attack detected. Let's check with the other case. Let's apply filter to this. So here for the first class label, I have entered the last test case. So these are the parameters that I've given as the input. Let's click on predict. So this input will be pre-processed at the backend and then train model will be giving us a prediction. And here we got the prediction that boot attack is detected, BOT attack is detected. Let's try with the one more case. Click on CIC IDS 2017. Let's check with the class label 2. Click on OK. So here I have entered all the parameters. Now let's click on predict. And here we got the prediction as brute force attack is detected. So here brute force attack is detected. Now let's check with the one more test case. Let's check with this fourth case. Click on OK. Let's give the input as we are doing prediction. for the CIC IDS 2017. Let's click on that. So here I have entered all the inputs of the first test case for the third class label. Now let's click on predict. And here we got the prediction that DDoS attack is detected, and the type of attack is nothing but the DDoS attack. Let us check with the one more test case. Let's try with the fourth one. So let us enter these inputs. Copy the forward packet, backward packet length, forward packet length, forward packet length max, backward max. The next one we have is backward packet length, forward packet length, forward packet, that is IET. Next one we have is forward header length, 144, backward header length. So next one we have is backward header length, backward length max, backward length mean, packet length standard deviation, average packet size, average forward segment size, average backward size, subflow backward bytes, subflow backward bytes, initial backward bytes. Now click on predict. So here we got the prediction as attack is detected, and that attack is nothing but the DDoS attack. So now let's do the prediction for the last dataset, that is CIC IDS 2018 dataset. So click on that. Here we are supposed to give the inputs. Let's open the sample cases of 2018 one. So these are the sample case of 2018. And here also we have total 7 classes. Sorry, 5 classes we have. Let's check with this one. Click on OK. So here also we have same parameters as 2017 CIC IDS 2017 dataset. So let's enter these inputs. So let's enter these parameters. We are checking for the zero label attack. So let's enter the first test case where the forward packets length is 935. Backward packets length is 293. And the next one we have is 935. Forward packet length mean is 187. Forward packet length standard deviation is 418, 14.7. Backward length max is 293. Backward packet mean is 97.4. So the next one we have is backward packet length standard deviation, forward IAT, length packet, that is packet length maximum, packet length mean, packet length standard deviation, packet length variance, average packet size, average forward segment size, average backward segment size, subflow forward bytes, subflow backward bytes, and the last one is init forward win bytes. Let's click on predict. Input is being processed at the backend, so that is why it is taking time to give us a prediction. So just wait for a while. And here we got the prediction that there is no attack and it is benign. So let's try with the one more class label, that is one label attack. So click on that. Okay. As you're doing prediction for the 2018, click on that. Give the inputs. So let's try with this case where forward packet length total is 1912, backward packet length total is 2665, forward packet length size is 640, forward packet length mean is 91.0762. The next one we are supposed to enter is forward packet length standard deviation, backward packet length max, backward packet length mean, backward packet length standard deviation, forward IIT total, packet length max, packet length mean, packet length standard deviation, packet length variance, average packet size, average forward segment size, average backward segment size, subflow forward bytes, subflow backward bytes, initial, forward, win bytes. Let's click on predict. And here we got the prediction and it is detected as BOT attack. So let's check with the other test case for the same data set. Click on CIC IDS 2018. So let's check with the class 2. So I have entered the first test case of label 2 and here are those. Let's click on predict. Input will be processed at the backend and then we will be getting the prediction. So just wait for the prediction. And here we got the prediction that attack is detected and that attack type is brute force attack. So now let's check with the other class, that is the class 3. Click on OK. Let's enter the first case. So here if you observe, I have entered the first test case. And now let's click on predict. Input is being processed at the backend. And now we got the prediction. So here we got prediction that attack is detected and the attack type is DDoS. Let's check with the last test case of the last data set. So the last class label is 4. Click on that, click on OK. Now let's try with the first test case of the class label 4. Here we need to give the forward packet length, backward packet, copy it, forward packet length max, forward packet length mean, forward packet length standard deviation, backward packet length mean, backward packet length standard deviation. The next one we are supposed to enter is, we have gone somewhere wrong, let's enter them again. So the first one is 565, 3436, 565. So yeah, they're correct only. Here we need to give this one. That is forward IIT total. The next one is packet length max, packet length mean, packet length standard deviation, packet length variance, average packet size, average forward segment size, average backward segment size, subflow forward bytes. So here we are supposed to enter the subflow backward bytes. The last one is init forward win bytes. Now click on predict. So here we got the prediction that attack is detected and the attack type is SQL injection attack. So in this way, just by giving inputs according to the data sets, then we will be getting the detections. If there is attack detected, it will detect which type of attack it is. If there is no attack, it will detect as no attack or benign. Let's check with the graphs. So let's check for the NSL KDD dataset graph. Click on that. So this is the sample outcome graph of NSL KDD dataset. So this shows the distribution of each class. Here on x-axis we have the target class and on y-axis we have the count. So these are the total 5 different types of attacks, which is normal. That means there is no attack. And here we have DOS attack, prob attack, R2L, and U2R. Here, if you observe, there is class imbalance, which means that U2R, R2L, and prob are in less count. So that is why we have used sampling techniques. And this is the original data. So this means the algorithms are trained on the original data where the sampling techniques are not used. Here on x-axis, we have accuracy score, and on y-axis, we have the algorithm names. Similarly, here we have precision score, recall score, FN score. And here we have algorithms trained on the random undersampling technique. So from the data, on the data, random undersampling technique is applied to rectify the class imbalance. And then the algorithms are trained on that. And here we have precision score, recall score, FN score. And here on the dataset, we have used random oversampling technique to address the class imbalance using this technique. And these are the algorithms trained on the random oversampling technique. Similarly, precision, recall, FN score here we have. So here we have algorithms trained on the random undersampling technique, which means that from the data we have addressed the class imbalance issue using this random undersampling, and then algorithms are trained on that particular data, that has been addressed using random undersampling. So this is the accuracy comparison graph, this is the recall, this is the precision comparison graph, this is recall, and this is the FN comparison graph. And here class imbalance is addressed using random oversampling technique, and on that data algorithms are trained, and here we have their matrix comparison graphs. Accordingly, here we have combined sampling technique on which algorithms are trained. So now let's check with the KDD cup data set. So this is the graph we have for that is sample outcome graph for the KDD cup data set. This is a sample outcome graph. Here on x-axis we have the target class and on y-axis we have the count. Here if you observe there is class imbalance. So here we have total 5 different attacks where U2R has very least count and U2 that is R2L also has the least count. Moving on, this is the accuracy comparison graph that is algorithms built on the original data where class imbalance has been not addressed. And here we have precision score, recall score, FN score. And here we have addressed the class imbalance using this random undersampling technique and algorithms are trained on that. So here we have all those graphs. We have addressed using random oversampling and also the combining sampling technique. Similarly, we will be having for CIC IDS 2017 and also CIC IDS 2018. Now let's log out. In this way, just by giving input to the system, it will detect which type of attack it is. If there is attack, it will detect which type of attack. It may be prob, it may be U2R, it may be R2L, it may be DOS, SQL injection. It may be any kind of attack. It will detect if there is attack in it, and that will type of that particular attack. And if there is no attack, it will detect as normal or either benign. And this will help all the people who are using all the digital devices. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.